All right, we're back and we're going to look at a couple more of these problems for Unit 3, the WAMAP practice test. First one is, excuse me, 1/4 x minus 4 is equal to 2/5 x minus 1/20. Okay, so we're going to use algebraic manipulation, like terms. We're going to put those together and put all the x's on one side, all the x values on one side, and all the other values on the right side. So what I'd like to start with is getting rid of that negative 4. So we're going to add 4 to both sides. And these 4's cancel out, leaving 1/4 x. And that's equal to 2/5 x. And then we got negative 1/20. So 4, positive 4 minus 1/20. So to do that, we're going to put 4 over 1. And we're going to subtract 1/20. I wrote 12th over there. It's been a long day. But I'm having another cup of coffee, so I should be good. 4 minus 1/20. And in order to have the denominators match, we have to multiply this denominator by 20. If we do that, we have to also multiply the numerator by the same amount, which makes this then 80 over 20 minus 1 over 20. And that gives us 79 over 20. Okay, so we can rewrite this as 1/4 x is equal to 2/5 x. And this was negative, but here it's positive. So we're adding, it's become a positive number, positive 79/20. Okay. Now we want to get rid of the x value. We say move it to the other side. So we do that by subtracting it from both sides. 2/5 x. These two go away, leaving just 79/20. And then we have 1/4 x minus 2/5 x. We need to find a denominator we can use for these two fractions. And one easy way is to use a prime factorization. So what you do is you take the numbers you're looking at and break them down by primes using only prime numbers. So the prime factorization of 4 is 2 times 2. And every number has a unique prime factorization. It's like a zip code. It only leads to one place. And then prime factorization of 5 is just 5, or 5 and 1. 1 is not a prime number, but it's prime. Number 5 is itself a prime number. So we're going to take these two factors and this one, and we're going to multiply them all together to get a number that will work as a denominator for 4 and 5. 2 times 2 is 4, times 5 is 20. So 20 will work as a denominator, and you may have been able to see that already. That's great if you can see it for lower numbers, but then when numbers get bigger, it's harder to see. So if you keep this prime factorization tool in your toolkit, it'll come in handy sometime when you've got big numbers like 88 and 27 or something like that. All right, so we're going to change these to 20ths. So we're going to multiply this fraction by 5 over 5, which is the equivalent of 1, and that's why it's an equivalent fraction. The value isn't changed, but it looks very different. So we're going to have 5 over 20 minus 8 over 20. And that's going to give us negative, oops, and these are x values, right? X, oops, x. So we're going to have negative 3x, right? Negative 3x is equal to 79 over 20. Okay, I wrote that wrong. I need to correct it. This doesn't go there. It's negative 3/20 x is equal to 79/20. So sometimes with all the fractions, it gets confusing and distracting, but just persevere. Sometimes if you imagine a whole number here, if this was negative 2x, what would we divide by to get rid of the negative 2? So the answer is always the inverse operation. So the inverse operation of multiplication is division, and you always use the number as it is. So we're going to divide by negative 3/20. And we're just going to write it this way. Cross that out, that leaves x, right? 1x or x. And then we also have to divide this guy by negative 3/20. And when you do that, division of fractions is inverting and multiplying. So we leave the first fraction the same way it is, and we multiply it by the inverse of the other fraction. And generally, negative signs stay in the numerator, so we're just going to leave the negative sign upstairs. And we're going to do cross cancellation here with this fraction. And we've got 20 in the numerator and 20 in the denominator. So 20 divided by 20 is 1. Negative 20 divided by 20 is negative 1. So then we have 79 times negative 1, that's negative 79. And then we have 1 times 3. Which is 3. Sorry, just had to check what I was saying and thinking. All right, and so that's what x is equal to. So the one way to test this all is to plug x in up here at the top of the page. X can go into here, this original formula. And let's see if that works, because it doesn't seem likely. But if it does, then that's the cool part. It just seems like such a random number. And we're going to plug that in. So let me rewrite the original. We have 1/4 x minus 4 is equal to 2/5 x minus 1/20. Okay, and this is like a substitution problem you might have in math. X is equal to negative 79 over 3. So let's plug that in and see what we get. We'll do this in victorious purple. 1/4 times negative 79 over 3 minus 4. That's supposed to be equal to 2 over 5 times negative 79 over 3 minus 1 over 20. Okay, so let's just calculate these out. 1 times negative 79 is negative 79. 4 times 3 is 12 minus 4. And that's supposed to be equal to this. So minus 4, we can turn 4 into a fraction very easily. Let's put it over 1. And then we need a 12 in the denominator. That means we have to multiply the numerator by 12 also. So we're going to have negative 79 twelfths minus, this is 48 twelfths. And that's supposed to be equal to whatever we get over here. So 2 times negative 79 is going to be the same as 2 times 80 minus 2, so 160, negative 158, 158. And then that's over 5 times 3, which is 15. And then we're subtracting 1/20. So let's look at negative 79 twelfths minus 48 twelfths. So this is a negative number getting more negative. So we're going to combine the 79 and the 48 and keep the negative sign. So that's like 80 plus 47. See how I did that? So negative 127 over 12. And that's supposed to be equal to whatever this is. So here we have denominators 15 and 20. So what would be a good denominator for those? Let's do a prime factorization and find our least common multiple. So the lowest prime that goes into 15 is 3. It goes in evenly. And then 5. So 3 times 5 is 15. Those are both prime. So we're done there. Lowest prime that goes into 20 is 2, leaving 10. Lowest prime that goes into 10 is 2, leaving 5. And we have our prime factorization. So we need to take the 3 from here and the 2's from here. And then each of these just produced 1 5, so it doesn't matter which one we take. We just take 1 though, okay? If one had 2 5's, then we would go with that. You always want to take the one that you have more of. And the reason is you need to have those those factors have certain properties, and you need to have each one represented. So we multiply these factors all together. We have 2 times 2 is 4, times 3 is 12, times 5 is 60. So 60 will work well as a denominator here. We have something over 60 minus something over 60. And to take 20 up to 60, we have to multiply by 3. So same with the numerator. So we get 3 over 60 for the equivalent fraction. And over here we have 4. 15 times 4, negative 158 times 4. So let's do negative, let's get some bright color up here. We're going to do 4 times 158. 4 times 8 is 32, carry the 3. 4 times 5 is 20, plus 3 is 23, carry the 2. And 4 times 1 is 4, plus 2 more is 6. So we've got negative 632, right? Don't forget your sign. Over 60 minus 3 over 60. So 632 minus 3 goes up by 3, right? You got a total of negative 3, negative 632, that's negative 635 over 60. So these numbers are both divisible by 5, so should we take out a 5? You guys know that from your divisibility rules, right? All right, let's do it in a fun color. Yellow. Should we try yellow? All right, divide this by 5 and divide this by 5. 60 divided by 5 is 12. And what about 635 divided by 5? Well, 6 divided by 5 is 1. And there's 1 left over. 13 divided by 5 is 2. And there's 3 left over. 35 divided by 5 is 7. And the number's negative, so this is also negative. So it looks like negative 127 is equal to negative 127. So negative 127 twelfths is equal to negative 127 twelfths. So our value for x was correct. This is our final answer, and that's what we'll put in here at, where are we? Negative 79 thirds. Negative 79 over 3, and that's how you write it, and no problem with the syntax, okay? So this video has already been 12 minutes. I'm just going to do this one on this, and then we'll come back with number 6 in the next one. Stay tuned.